Good morning, sir. My name is Sam Bhaskar. My roll number is 33. I am from EC department. My course is about electromagnetic waves and transmission lines. My topic is about who was James Maxwell and what was and uh, and his electromagnetic theory. So, coming to introduction, James Clerk Maxwell. He was born on 1831 and died at 1879. He was a Scottish physiologist and mathematician who made groundbreaking contributions to the field of electromagnetic and optics and statistical mechanics. His formulation of Maxwell equations unveiled electricity, magnetism, and light into a single theoretical framework, paving the way of modern physics. Maxwell's electromagnetic theory remains one of the most significant scientific achievements, forming the foundation for technologies such as radio, televisions, and wireless communications. So, this is the introduction for James Clerk Maxwell. And who was the James Maxwell? Earlier life and education. He was born on June 13, 1833 in Scotland. Shown as earlier talent for mathematics and science, publishing his first scientific paper at the just age of 14 years old. Studied at the University of Edinburgh, and later at Trinity College, Cambridge, where he excelled in mathematics. Before a professor at a college and later at King's College, London. He was the James Clerk Maxwell. Mm, Next, major contributions to science: electromagnetic theory, Maxwell equations, electricity and magnetism into a single set of equations. Kinetic theory of gases developed the Maxwell-Boltzmann distribution, explaining gas molecular behavior. Color theory and optics developed the first color photograph and contributed to understanding of color perception. Certain things explain their stability to mathematical analysis. Maxwell Demon, a thought experiment questioning the second law of thermodynamics. Death and legacy. Passed away on November 5th, 1879, at the age of 48 from stomach cancer. He worked laid the foundation for many technology advancements, influencing external and the development of quantum mechanics and relativity. Maxwell electromagnetic theory. Historical context. Before Maxwell works, electricity and magnetism were studied separately. Scientists like Christian and Mary, Henry Marie Ampere, Michael Faraday, and Gauss has discovered various laws concerning electrical and magnetic phenomena, but there was no unfiled theory linking them. Maxwell's greatest achievements was to bring all these discoveries together into a single England mathematical framework known today as Maxwell equations. So this is a Maxwell's equation, the foundation of electromagnetism. Maxwell formed four fundamental equations that describe the behavior of electric and magnetic fields. Gauss law for electricity. E is equals to density by epsilon naught. Delta is equals to rho by epsilon naught. Describes how electricity changes, creates electric fields, states that the total electric flux through a closed surface is proportional to the large enclosed. Gauss law for magnetism. Delta into B is equals to 0 states that there are no magnetic monopoles, magnetic field lines away from closed loops. Farad laws of induction. Delta into E minus rho B by rho T describe how a changing magnetic field creates an electric field. Ampere's law with Maxwell addiction. Del, uh, Delta into B into omega naught j plus omega epsilon naught rho e by rho t. Describe how electric currents and changing electric fields generate magnetic fields. Im- Implication of Maxwell's equation and field electricity and magnetism show that electricity and magnetic field are linked. Predicted electromagnetic waves derives the wave equation proving that light itself is an electromagnetic wave. Determine the speed of light is c is equals to 1 by under root u naught epsilon naught. Maxwell calculated the speed of electromagnetic waves, finding it to be close to the measured speed of light, leading to the conclusion that light is an electromagnetic wave. Laid the foundation of wireless communication. His equation directly lead to the work of who proved that existence of radio waves and who developed wireless telegraphy. The impact of Maxwell's electromagnetic theory. First one is classical physics and electromagnetic wave theory. Maxwell's theory classically physics providing a complete description of electromagnetism and laying the groundwork for optics and field electromagnetism. Wave propagation, understanding audio, microwave, and visible light waves. Electromagnetic spectrum, discovery of radio waves, X rays, and gamma rays. So, second one is about modern physics. Einstein and the radio of relativity. Einstein regarding Maxwell equations are the most profound and fruitful that physics are never experienced. Inspired special relatable 105 that constants of speed of light in Maxwell equations that a key motivation of Einstein theory. So technologically innovations. Maxwell electromagnetic theory that led to numerous technologies that define the modern world. Radio and television is one of the thing. Transmission of electromagnetic waves for communication in radio and televisions. Coming to wireless communication, mobile phones, Wi-Fi, Bluetooth, and satellite communications are the technology innovations. Medical imaging, MRI, resonance imaging relies on electromagnetic principles. Electrons and power generations, electric motors, transformers, and generators. These are the technological innovations. Maxwell's theories today. Despite being over 150 years old, Maxwell's theories is still fundamental to the modern physics. Some modern applications include quantum electrodynamics (QED), the quantum version of electromagnetism developed by Richard Feynman and others. Electromagnetic field manipulated used in metamaterials for clocking devices and advanced options. High speed internet and telecommunications. Fiber optics and wireless data transmission rely on Maxwell principles. So, coming to conclusion, James Clerk Maxwell was one of the most influential physicians in history who was revolutionized our understanding of electromagnetism. His electromagnetic theory unveiled electricity, magnetism, and optics into a single mathematical framework, leading to the discovery that light is an electromagnetic wave. Maxwell's four equation remains fundamental to the model physics up to now in engineering also, forming the basic of a technology such as radio and wireless communications, power generations, and medical imaging. Even today, Maxwell's contribution continued to shape scientific advancements from quantum electrodynamics to high-speed telecommunications. His legacy is a testament to the power of mathematical elegance in explaining the nature world, earning you to the place alongside Newton and Einstein as the one of the greatest physicians of the all time. So coming to the Maxwell theory, this is a Maxwell electromagnetic theory. Here we can see the formula of these equations where Maxwell wrote about foundation of electromagnetism, and he has that starting from his James Clerk Maxwell. He has written the three formulas where we are using in engineering up to now. Until now he wrote behind 150 years ago, still we are using about these formulas in electromagnetic waves. So this is about the introduction which I have already read, and this slide is about the who was this Maxwell and his photo, and these are the major contributions to science, and his death and legacy, and his theories what he wrote about in electromagnetic theory, and his equations, Gauss law of magnetism, Faraday law of induction, Ampere's law, and determine the speed of light equations, and the impact of Maxwell electromagnetic theory. This is a modern physics, Einstein and theory of relatives, and it's a technical innovations, radio and television, wireless communication, medical imaging, electronics and power generation. These are the Maxwell theories today, like QED, electromagnetic field magnification, high-speed internet data, and telecommunication. This is the conclusion behind it. So thank you. This was the topic about who was the Maxwell and what he done to the physics, and physics is the topic of science, electromagnetic waves and transmission lines, and this are the topic is about who was the James Maxwell and what he has done in what his contribution in his electromagnetic theory. Thank you.